Welcome back, folks. So today we're going to embark upon another sponsored project from PCBWay. So what we're going to do is we're going to have another look at this MAX7219 7-segment LED display driver. So when we did have a look at that at the beginning of the month, we built this module here as a quick little way to test it out. And I kind of like that module. So I want to get one built up a little bit more formally. So I'm going to design one. I'm going to get PCBWay to make the PC boards for us. So I'm going to build some up. And then what we're going to do, we're going to go through a basics of microcontrollers, specifically the PICAXE microcontroller. Someone asked me if I would do a video about the basic setup for running a PICAXE microcontroller. And that's exactly what we're going to do. So when we get these modules back and build one up, I'll do that. I'll make a video about what the minimum requirements are for setting up and running a PICAXE microcontroller. And then I'll have those modules for later. They'll work with more than just a PICAXE. These modules will potentially work with anything, Arduino, ESP32, anything you want, even a Raspberry Pi or Raspberry Pi derivative of some kind. And then we're going to continue on with the series a little bit, and we're going to build up some more modules, and we're going to build up a platform similar to this. This one here is something I built up a decade or so ago as a part of a business that I had. So we'll build up something like this. You have a little development platform for working with PICAXE microcontrollers. And we'll try to make it as close to this as possible, yet easy enough for the average person to build. So we'll go with through-hole parts rather than any surface mount parts. And this particular board, and we'll make the new one the same, will work with any of the smaller M-series PICAXE microcontrollers, such as the 08 M2, the 14 M2, and the 20 M2. And they'll all go into this one board, and it can be programmed in there. And you can see that it's got access to all the pins, so you can plug in modules. And then we'll take that and we'll develop, like I say, we'll develop a couple more modules. And then I'm going to present to you the idea of modular design. So taking modules that you design, test, and prove, and then using the schematics for those to build up more complex designs. That's the goal anyway. Before we go on with this this particular module here, and I'll show you the design of it, let's have a word from our sponsor. PCBWay is a fantastic place to go and get your prototype PC boards made up. They make it so simple, they do it so quickly, and they just do it with extremely high quality. But once your prototype has been designed and finalized, and you want a custom case for it, where do you go for that? Well, PCBWay. They have complete sheet metal fabrication service, and they explain their process. They tell you what the capabilities are, what their sheet metal cutting types are, even give you the advantages and disadvantages. And they have a vast array of fabrication processes, materials, surface finishes, colors, anodization, powder coating. So you need a special case built up. It's just as easy as it is getting PCB boards made to get a quote from them. All you have to do is put your CAD files in place, tell them how many they want. It'll decide the design units from the CAD files you put in, but you can also put all this stuff in manually. Select your materials, select your colors, and submit your information, and they'll come back to you with a quote for what it's going to cost. It's just that easy. Anything you do at PCBWay is done easily, it's done quickly, and it's done right. Give them a try. All right, so here we have the basic schematic for it. It's pretty simple. We just got the MAX7219 down here, the display, and I'm going to be using an FJ5461AH. And it's the same display as I used in the little one that I made up for the MAX7219 video. And it's a nice little display. It's pretty standard, 0.56 inch. These ones in particular are red. You can get them in different colors, the same size, the same layout. Just be aware though that if you do have like a green or blue, it's going to change the voltage across the diode. So you're going to have to make consideration for this value here. 12K is fine for, you know, the 1.5 volts thereabouts that a red LED does, but you may have to change this value for larger voltages. And a little header here to access it, and a couple of capacitors, one for bypass and one for bulk. So very, very simple design. The PC board is just as simple too. Here it is. Here's the front. One of the things that I did do here, and I do this quite often in some designs, is in this particular case, we have the VCC and the ground are very close to each other, but having a capacitor on the outside of the chip somewhere leaves a lot to be desired in, you know, that minimum path for a bypass capacitor. So what you can do is that most sockets have a slot down the middle of them. Some of them might have a little bar in it, but I don't think the 20-pin socket does. So what I'll do is I'll put the capacitor right there in the middle, and the socket can go over it. It can be as close as possible then between VCC and ground and provide the best possible bypassing. The ground planes, they're not really ground planes here because the only way I could actually lay it out, it kind of couldn't do a ground plane type of scenario here. But what we do have is we have copper pores here. So the back one is ground. And you can see here all the ground connections go through that copper port too. So it should be very, very low impedance. And the front one is VCC. The same could be shown there. So here are all the VCC pins. Here's VCC over here and down here. So it's a very good connection. We have a trace underneath connecting from here to here, and then it goes into the copper pore. So it should be a good little board. And it's going to be a handy module. I've allowed here for mounting holes, so it can be mounted directly into projects if you want to carry it forward that way. And we'll send off these designs to PCBWay and have them build a board. And when they come back, we'll build one up and we'll show you the basic things you need to get started with PICAXE microcontrollers. Okay guys, that's all I had for you today. Oh, and we'll get back to the ZWE DSO3D12 on the next video. I just needed to get this off and in manufacturing so that I can get it built up in a reasonable amount of time. We'll see you in the next video. In the next video, we'll be back to the little ZWE oscilloscope. Bye-bye now.